All right, welcome back. This is the solution for the third problem from the second quiz. And in this problem, we're going to compute some integrals, but we don't want to use the fundamental theorem of calculus. Okay, this is a key instruction in this problem, right? Without using the fundamental theorem of calculus. Okay, so if we're going to solve this, then what are we going to rely on? Well, we need to rely on our knowledge that integration is just telling to accumulate, right? It's giving us the signed area between the graph of the curve and the positive t-axis. All right, so let's do a graph then. So this shouldn't be that hard to graph. 4t minus 3, that's just a linear function. So, and we're going from 3 to 7, so I don't need to do anything on the negative side. Now let's see here. It's 4t minus 3, so if we were going to go all the way to 0, we'd get an intercept of negative 3. But I really don't even want to go that far. Let's go from 3 to 7, and let's see, when t equals 3, so when t equals 3, 4t minus 3 equals, let's see, 12 minus 3 is 9. Okay, so we're going to scale this down a little bit so we have room, so that'll be 9. And what about when t equals 7? 4t minus 3, let's see, 4 times 7 is 28, minus 3 is 25. Okay, so this is definitely not to scale. Okay. So, and then we will connect the dots. All right, and so what does the integral represent? Well, remember we draw vertical lines at 3 and 7, and the integral represents this area in between the curve, 4t minus 3, and the t-axis. Okay, well this is just a trapezoid. So we need to find the area of a trapezoid, and as we saw in class, area of a trapezoid is going to be the length of the base. So in this case, how far from 3 to 7? That would be 7 minus 3, which is 4, times the average height. So on the left-hand side, you have a height of 9, and on the right-hand side, you have a height of 25. So we need to multiply by the average height, so that'll be 25 plus 9 over 2. Okay, so let's see. Well, nicely, the 4 and the 2 will give a little cancellation. I'll just get a 2 times 25 plus 9 is 34. And so 2 times 34 is 68. And so that will be the integral that we're looking for. Okay, now the second one looks a lot more complicated because this integrand is a lot more complicated than the linear function that we just dealt with. But let's write something down here. Let's say I knew that my function was called y, and y was equal to negative the square root of 16 minus t squared. If I square both sides, that would tell me that y squared, well, first, squaring will get rid of the negative. It will also get rid of the square root, and I'll just have 16 minus t squared. And adding t squared to both sides would tell me that t squared plus y squared is equal to 16. And this is the equation of a circle centered at the origin, right? So centered at 0, 0, with radius, well, 16 is 4 squared, so this will be radius 4. Okay, so this integrand is, well, it's not giving us the entire circle, but it is going to give us some piece of it. So let's draw a little graph. So this would be my circle with radius 4 centered at the origin. Now, I'm only allowed, actually, to let t go from 0 to 4. So I don't get anything on the left-hand side. So I'm only looking at stuff on the right-hand side. And because I'm taking the negative radical, that means all of my y values are supposed to be negative. So in fact, I'm only getting this stuff below the axis. Okay? In fact, let's redo that color, right? We've always in class done the below the axis in red. And that's important because we know that the answer now should be something negative. Okay, well, how much negative? Right? How much negative are we going to get? Well, it's a quarter of the circle. So all I need to know is what's the area of a circle with radius 4, and then I just want 1/4 of that. So area of circle with radius 4 equals, well, let's see. In general, the area would be pi times the square of the radius. So this will be pi times the square of the radius, which is 4. So that's 16 pi. Okay, so the entire circle would have area 16 pi, but we just want 1/4 of it, right? This one little quadrant down here. So this will be 16 pi cut into a fourth, or negative 4 pi.